And function statement. Actually, we already did that. What you did in the hello world in the first program was specifying the function, right? So here we are specifying add, multiply, increase. And we are taking input 1, input 2, and step here, right? Interestingly, this is common, right? The definition part of the function, so which you have to do in the script editor. Why don't you pause Why don't you pause a short time and just type in, and also type in this execution part in console and see what happens. Interestingly, strangely, we have 3 parameters here in the definition. And here we have 3 parameters. So num A matches input 1, num B matches input 2, and step 2 is 2 matches to this step 2, right? This is 1, 2, so it's 1, 2, 2. Means that what? 1 plus 2 is 3, and 1 multiplied by 2 is 2, and 1 plus step is what? 3. So these are things that we have. But this case, we don't have the other 2 parameters. Num A corresponds to the input 1. That's fine. But num B, num B and value 2, where are they? Actually, they are not. So it means that when the Matlab functions are executed, we can specify the lesser parameter sets than the definition part compared to the definition part. Then what happens if we only have the values for the input 1? Then what happens is that this if statements controls that. If n is number of argument in, so it's quite complicated thing, right? N is the number of argument in. So if number of argument in is less than 3, then step would be 1. So what we are doing is that we are setting up the default value, right? And number of argument in is less than 2 means that we only have input 1. In the case, input 2 equals 5. So we are specifying default values like this. So this function statement actually you specify function and end here, and this is function name, and these are the parameters, and these are the return values. Return values corresponds to the variable names inside of the Matlab function, out1, out2, out3, and this corresponds to the out1, out2, out3. So we actually don't need the return statement here. But interesting thing that we learned here is that how we can specify the default values for a certain function, right? Okay, so inline functions. So inline functions are like this. So when you are defining a function, you have to do like function, and we have brackets and equal and function name and the parameters and end block and the block statement, and then this is the block of doing things. If you are just creating a function that adds up to values, it's so much, right? It's so much. So that's what we do here. So inline, so f is the function name here, and inline is a kind of command to create a certain function doing x plus y. So here we can specify any arithmetic equations, okay? And x, y are the two parameters of the f. Okay, so domain of 1, 1, 2, and c is right 2, 3. So 2 corresponds to x, 3 corresponds to y, 5 corresponds to x, 7 corresponds to y, like that. Okay, so the number of parameters are specified, and inline function specified simple arithmetic functions, alright? Okay. And then later you can just call the function name here, which is f. Okay? Or you can use a shortened version of this. Write this. So this add is specifies the inline functions, right? This inline is corresponds to here. And then what happens is that x, y are the two parameters, params, and these are the equation to execute. Okay, and particularly this function name is called function handle. So this is a shortened version of function definition. So let's code something kind of very simple one, but also kind of interesting one. Let's find a prime numbers. So finding prime numbers is kind of important in many aspects in mathematics, also in probabilities and many things. And so why don't you code that? So why don't we just pause for a second to type in these function definitions, and then why don't you run your function at the console? Okay, so this is going to go to the console, and this is going to go to the script editor. Okay, right, I will pause. Okay, I think that now you finish the coding and you run your the program, and here it is. Here we are. So we have two parameters here. If the parameters are not given, then we have also default value setting, and it's used if and argument in, number of argument in, and so forth. And then here number of count is initialized to 1. See the camera casing here, and it's noun, so n is variable, so it's noun, and this n is small case. And then we have for loop here. For loop number num-param 1 to num-param 2. So here is 1 to 10 means that is 1, 2, 3, 4, 10, right? And then we have this if statement, which compares this. Thing is that we don't know what this is prime number I here means. And what we can see is that we have function inside functions. So this is function inside function. Very funny. And inside the function there is a is prime number, and so it matches up, and in corresponds to the ITR actually, and out is the out value, and then out is true at the moment for iterations 2 to in minus 1. So what we are doing is that we, for instance, if in is 5, we are dividing 2, 3, 4, and then if their modular is 0, then this 5 is completely divided by some value. Of course, it's not going to be. For instance, 4 is divided by 2 and modulo is 0, then we know that it's not a prime number. So returns false, out is defined as false. If there is no such value, then it will end this function and output will be true. So this is how we identify the prime number here. And then if fprint function here means that this %d specifies is printing out decimal value, right? So num count of the prime value, and ITR prime value itself are printed out like this. Okay, and then num count is plus 1. Okay, because it's prime number. So that's how our function works to find the prime numbers. Okay. So far we have been doing this the function definitions and flow controls and the loops and the string manipulations and so forth. These are all basics in the any programming languages, and we covered that in the Matlab setting. Okay. In the third part of this week, we are going to cover the class and instances in Matlab, how to define them, what they mean, and so forth. Okay, so this is the end of our second part of the week 1.